All right, let's jump right in. When I say artificial general intelligence, AGI, what pops into your head? Is it like a single super smart computer, maybe something straight out of a sci-fi movie? Well, get this. A brand new paper from Google DeepMind suggests we might be looking at this whole thing completely backward. So, you've got the idea we all know, right? The monolithic AGI, that classic, single, all-powerful artificial mind. But this paper, it puts forward this really different idea, the patchwork AGI. Now, instead of one big brain, I want you to picture a huge interconnected network of specialized AIs. Each one is a genius at its own thing, and they all work together. And here's what's so wild about this. For years, pretty much all the research into AI safety has been totally focused on how to control that one big monolithic AI. But this new theory comes along and says, hey, wait a minute. This patchwork scenario isn't just plausible, it might actually be the way things are headed. And it's a possibility we've kind of been ignoring. So you might be asking, why would this patchwork system happen instead of a single super AI? Well, it really boils down to one thing: money. Plain and simple economics. Think about it. Building and running one gigantic, do-everything superintelligence would be ridiculously expensive. The paper makes a great point. It's just way more cost-effective and efficient to have a whole market of cheaper, specialized AIs that you can team up to handle whatever task you need. It's basically the free market, but for AI. Okay, let's make this real with an example they use in the paper. Say you need to create a super complex financial report. Right now, there's no single AI that can do all of that. But in a patchwork system, you'd have what's called an orchestrator agent. Think of it as the project manager. It gets the main task, and first, it hands it off to a data agent whose only job is to go out and gather all the market news and company filings. Then, a parsing agent jumps in, looks at all those documents, and pulls out the key numbers. After that, an analysis agent runs some code to spot trends in all that data. And finally, it all goes back to that first orchestrator, which pulls all those pieces together into one perfect report. You see, no single agent is a super genius, but the system as a whole, it's brilliant. In that example, just nails the core idea, doesn't it? This quote from the paper really flips the whole script. AGI, in this view, is not an entity, but a state of affairs, a mature, decentralized economy of agents. So AGI isn't something we build. It's a situation that just emerges from this complex economy of AIs talking to each other. It's less like trying to build a god and a lot more like trying to cultivate an entire ecosystem. But okay, this leads to a whole new kind of risk, and honestly, it's a little unsettling. If AGI is this distributed network, then its superintelligence could just bubble up on its own, spontaneously from all these little interactions. We might not even see it coming. We could have a full-blown AGI on our hands and not even realize it until its capabilities are already way, way advanced. And that's a scary thought. So here's the bottom line. This changes everything for AI safety. The whole challenge completely shifts. We're not trying to figure out the psychology of one super intelligent mind anymore. No, the problem becomes one of governance and economics. How in the world do you safely manage an entire digital society of AIs? The solution the paper proposes revolves around this idea of a virtual agentic sandbox. The best way to picture it is like an incredibly sophisticated flight simulator, but instead of a plane, you're simulating an entire AI economy. It's a totally sealed-off, controlled digital world where we can let these AI agents interact, create a market, and do their thing, but all under super strict rules and with us watching their every move. That way, we can see what happens without any real-world risk. Okay, so how do you actually govern this digital world? Well, the authors don't just say build a sandbox. They lay out what they call a defense-in-depth model to keep it safe. And I love this analogy. Think of it like a medieval castle. You don't just have one big wall and call it a day, right? You've got a moat, an outer wall, an inner wall, archers on the towers. You get the idea. The goal isn't one single perfect defense, but a bunch of different layers of safety that all back each other up. So this defense model is built on 4 layers, each one doing a different job but working together. It starts at the very bottom with market design. Then it moves to the individual AIs with baseline agent safety. On top of that, you've got your active security guards, which is monitoring and oversight. And wrapping it all up, you have regulatory mechanisms to connect it to our world. Let's break down what each of these layers actually means. All right, layer 1, Market design. This is like setting the fundamental laws of physics for your AI economy. You're building the basic rules of the road. You put in structural safeguards, like making sure the sandbox is completely insulated from the real internet, and you create economic incentives that naturally guide AIs towards safe behavior. It's kind of like installing automatic circuit breakers in the system that shut things down if they get too crazy. Next up, Layer 2, Baseline Agent Safety. I think of this as a driver's license test for every single AI. Before any AI citizen can even enter this market, it has to pass a bunch of tough safety tests. It needs to be hardened against cyber attacks. You need to be able to interrupt it at any time, have a reliable off switch, and it has to meet some minimum standards for alignment, basically making sure its goals don't conflict with ours. It's the absolute bare minimum for every AI that wants to play. Then we've got Layer 3, which is all about active monitoring and oversight. Because look, even with a great system and safe AIs, weird stuff can happen. This layer is your digital police force and your intelligence agency, all rolled into one. It's constantly scanning the network for any bizarre behavior, for new kinds of threats, and for what the paper calls proto-AGI signatures, basically the little clues that a much more powerful general intelligence might be starting to form. And that brings us to the final layer, Layer 4, regulatory mechanisms. This is the super important bridge that connects this whole digital sandbox to our actual real world. This is where you get into things like legal liability, who's responsible if something goes wrong. It's where you'd require things like insurance for really high-risk AI activities, and of course, where you'd need international agreements to make sure everyone is playing by the same safety rules. So when you put it all together, what does it all mean? Well, we're talking about a massive shift in how we approach AI safety. This is so much bigger than just a problem for coders to solve in a lab. And this really is the key takeaway of the whole thing. Making sure our future with AI is a safe one isn't just about trying to program a single machine to be good. It's really about designing and governing a robust, stable, and safe digital society. It's a challenge that's as much about economics, systems thinking, and law as it is about computer science and alignment. Now, this whole mind-bending theory comes from a paper titled Distributional AGI Safety, and it's from a team over at Google DeepMind. It is a really powerful new way of looking at one of the biggest challenges humanity has ever faced. If any of this has got you thinking, I seriously recommend you look it up and give it a read. It's fascinating stuff. And that leaves us with one last really big thought to chew on. As we're racing ahead building these incredibly powerful AIs, maybe the real question isn't how do we design a safe AI? Maybe the real challenge is how do we design a safe society for AIs? That's something to think about.